We are on page 119 from your lab manual, and we are going to study the two demos here. The first demo of cobalt we are studying today is a cobalt chloride equation equilibrium, which is the second one on page 119, and we are going to study the temperature and concentration dependence. So here I have 5 different tubes here of the same size, to which I put a solution of methanolic cobalt chloride. So first thing I want you to do is look at the color of this solution, and you need to record the color of methanolic cobalt chloride 6H2O solution. That's the initial color. Go ahead and record that on the first line. And then what we are going to do is we are going to take two tubes. The first tube I'm going to put in a hot water beaker with hot water, and then we take another tube, and it is the same methanolic cobalt chloride water. We are going to put in a beaker with ice, and that's to look for the temperature dependence. So one in hot water and one in ice. And I'm going to put these aside, and we'll come back to them and see the color changes. So then out of the other 3 tubes of methanolic cobalt chloride, I'm going to reserve this as my control experiment so we can compare the colors to that, and take the other tube here, number 3, and to that I'm going to put some water. If you look at the equilibrium reaction, you have water on the reactant side, so we are going to put some water and see what happens. Okay, there is a color change that is happening. So the control initial color was more purplish. Now it's going to go to pink. All right, I hope you notice the difference in the two colors. So adding water, and water is on the left side of the equilibrium. So when you add water, you should know the equilibrium is shifting to the opposite side, which would be the right side. So the color on the right side should be pink. To the other tube, I'm going to add some hydrochloric acid. I have hydrochloric acid here, so I'm going to put some hydrochloric acid concentrated. So let's see what happens. Hydrochloric acid gives Cl minus ion, and that's on the product side of our equilibrium. So let's add that hydrochloric acid. Okay, and we see a color change already, and compare that to the control tube, and that's more purplish color versus it's a more blue violet color with the addition of hydrochloric acid. So HCl adds Cl minus, which is on the product side, and we just added Cl minus by adding hydrochloric acid. So therefore the equilibrium should shift to the left side, and therefore the color on the left side should be more like a dark blue violet. All right, let's see if we can reverse what we just did. We add deionized water to the one we added hydrochloric acid, and okay, what do we see? A pink color. So that deep blue violet color went to a pink color. In other words, we were able to reverse that equilibrium shift. Now let's see if we can add hydrochloric acid to the one we added deionized water initially, and see what it does. Okay, so that's hydrochloric acid, and you can already see that it's changing color, and we keep adding because I probably added a lot of water initially, and it should go to that deep blue violet color. So remember the equilibrium shift that we saw initially, and now it's going to in the opposite direction. So now we got a blue violet color. That's more purplish, and that's a blue violet, and that's a pink. So you should know which ions we are adding and which direction the equilibrium is shifting. So the most important thing to learn here is that depending on the ions or the ligands, that they are combining with, cobalt will show different colors, and that's the purpose of this equilibrium reaction. Now let's go back to what we did initially to see what we had. We had a container of hot water, and in hot water our initial color was purple, and in hot water it became deep blue violet. So how do we interpret that reaction, or that color change? So when you applied heat, it went to deep blue violet, and also when you added Cl minus, it went to deep blue violet. So heat must be added to the product side in order to shift the equilibrium to the left side to get a deep blue violet color compared to the purple color. So then we look at the one that was in the ice bath, and the ice bath, move this away. Okay, so it's going to a pink color. So in the ice bath the color is pink, earlier it was purple. So therefore, by cooling, it is going to shift the equilibrium to the right side. Now, let's see if we can reverse the effect of that. The one that was in the ice bath, I'm going to put in the hot water, and the one that was in hot water, I'm going to move to the ice bath to see if we can reverse this equilibrium shift. So that might take a couple of minutes. We can give it a few minutes, and we can look at it. You can already see that the color is changing in here on the top, and and you'll see the color is already changing on the bottom to a pink color. So purple is going to go to a pink color, and here the pink is going to go to a purple color, which is actually not purple, which is a deep blue violet, because you're comparing it to the purple. This is the original, this is the deep blue violet. So, all right. And then if you look at the bottom of it, this is turning pink. So that tells us that this reaction can be reversed, and it is a reversible reaction.